All right. Equations of lines. So this is going to be related to that slope-intercept form of that we talked about in the lab there, but we're going to talk about the three different forms of equations of lines. The first form is called point-slope form. Point-slope form. With point-slope form, you have y minus y1 equals m x minus x1. You have two things. You have a slope, and that's the m. And then you have a point, an ordered pair. And that's the x1, comma, y1. That's the x1, that's the y1. Okay? So with point slope form, you've got a slope and an ordered pair. That ordered pair is different than slope intercept form because that ordered pair doesn't have to be the y-intercept. It can be any point on the line. That's the difference in point slope form and slope intercept form, is that point slope form can be any point on the line. The slope's still going to be the same as it would be in slope intercept form, but the point can be any point. It doesn't have to be the y-intercept. If you remember from the lab we just did, that's the form that last equation was in on lab 11, the number 8. That equation was in point slope form, and we put it in slope intercept form. So what we're going to do is we're going to write equations in point slope form from the information given. So our first example tells us to write the equation of a line through the ordered pair -4, +1 with a slope of -3 in point slope form. Point-slope. So point slope form is what we're going to go for. So I'm going to write down the point slope form again. Y minus y1 equals m x minus x1. So in this description here, this is x1, this is y1, this is m. All I'm doing is putting that stuff in there. So y minus 1 equals -3 parentheses x minus -4. The only thing we have to do with point slope form to finish the problem is clean up any double negatives that we have. So we got one double negative in there. We got that minus -4. So we're going to clean up that double negative and rewrite that as y minus 1 equals -3 x plus 4. That is my point slope form, the finished point slope form. So if they give me a slope and any ordered pair on the line that the line goes through, I can write my equation in point slope form just by plugging those things in and then simplifying as I can.
Can you say that one more time, please?
So if they give me a slope and any point, so it doesn't have to be the y-intercept, it can be any point on the line, I just plug the slope in and the ordered pair, and I got my point slope form. I just got to simplify the double negatives. That's all I have to do to make it finished. If they ask for it in point slope form. Sometimes they're going to ask for it in point slope. Sometimes they're going to ask for it in slope intercept. Sometimes they may ask for it in what's called standard form. Those are our three forms that we're going to talk about in this section. Okay. So let's do another problem that's point slope form. Okay. So point slope form for a line through -3, +2, and 2, -4. But Mr. Isbell, you just said that they have to give me a slope and a point for me to put it in slope-intercept or point-slope form. They didn't give me a slope, but they gave me 2 points. So I can get a slope from 2 points. So this is where we did that in lab just a minute ago. We use our slope formula to find the slope, and then we pick one of those ordered pairs for the point. So there's really 2 correct answers to this one. There's a one if we use the point -3, 2, and a different equation if we use the point 2, -4, but they're the same line. So let's find the slope first. So I'm going to take my y values and subtract them on the top. I'm going to do -4 minus 2. And then since I started with -4, I'm going to have to start with +2 on the bottom, minus -3. So on the top, I get -4 minus 2 is -6. On the bottom, I've got +5. Is that what you guys got? Then a double negative there makes it a plus. So my slope is -6/5. Now I have a slope and an ordered pair. That's the 2 things I need to write a point-slope form of equations. So if I use the point -3, 2, my point-slope form looks like this. Y minus 2 equals -6/5 x minus -3. And then I got to clean it up a little bit because I got a double negative there. That's a correct answer. If I use the point -3, 2. But if I use the point 2, -4, I'm going to have y minus -4 equals -6/5 x minus 2. Got to clean that up a little bit. I got a double negative on the y side. That's going to be y plus 4 equals -6/5 x minus 2. That is also correct.
So any question like this, there's gonna be 2 possible answers?
Yes, be 2 possible answers. And it would depend on which ordered pair you decide to use. So when you look at a multiple choice format, you got to look at it and say, okay, which ordered pair did they use? And that's the one I want to use. So looking at your over here, that really tells the tale about which ordered pair they used here. So when you look for that, kind of you'll know which ordered pair to try to use to find that.
But doesn't the point slope form tell us which one to use for this y1 and x1s?
Well, it depends on which, because we have 2 different ordered pairs there. We don't really know which, it doesn't matter which one we use because we find the slope, and then the only thing that makes this kind of hairy a little bit is the fact that on a multiple choice format of a quiz, you could have 2 possible answers. But the answers on the multiple choice, there'll only be one correct one.
Okay. When you graph this, it's the same line.
Yes, that's exactly right, John. When you graph it, it's going to be the same line.
It's just different points.
It's just different points on that line. That's exactly the point right there. That's exactly the right thing to be thinking about. This is the same line, but it's just we're using a different spot on that line to get the equation. That's all that this is. Okay? All right? So from point slope form, it is really easy to get into slope intercept form, which we've already talked about a little bit tonight. Slope intercept form, you have y equals mx plus b. You have 2 things. You have the slope and the y-intercept. That ordered pair on the y-intercept is 0, b. So sometimes they may give you a slope and an ordered pair, but that ordered pair is special if it has a 0 as the x, because that means it's the y-intercept. So that allows you to go straight to it. Okay? So let's write an equation of a line. So for example C, let's write the equation, or write the slope-intercept equation for a line with a slope of -2 going through 0, -5. So in this case, they gave me an ordered pair, but that ordered pair is really special because it has 0 as the x value. That means that this is my m, and then the -5 is my b, because the y value in an ordered pair that has a 0 as x is the y-intercept. Okay? So we can go straight to our equation in slope-intercept form. I know the slope is -2, so I put that in front of x. I know my y-intercept is -5. I could write plus -5, but I'm gonna save myself a little bit of writing and write just -5. That's how you would expect to see that. Now, the neat thing is, if I started with point slope form and did this same work with point slope form, I'd put y minus -5 is equal to -2 x minus 0. What's x minus 0? X. So on the right-hand side, I really just have -2x, correct? And then on the left side, I got y plus 5, because that double negative thing. How do I get y by itself? Ooh, that's nice. So that's going to be y equals -2x minus 5. So we can get to slope-intercept form through point slope form by just plugging it in there. That actually works no matter what the point is. If it's not the y-intercept, we can still go through point slope form to get the slope-intercept form. Okay? Now, if they gave me this, I'm going straight there. If they want slope-intercept form and they gave me the y-intercept, I'm going straight there. I'm not doing this. But if they don't give me the y-intercept like they did right here, I have to do this, that's not that many steps. That's not too bad. I can still do that. Okay? So if they give me the y-intercept, go straight to y equals mx plus b. That's the easiest thing to do. But if they give you something like this example, so we want the slope-intercept form of a line, not a ling, but a line, through -4, +1, with a slope of -3. Okay? I'm going to show you two different ways to do this, and both ways get you the same answer. The first way is through point slope, which I like this way because it makes me practice point slope. In algebra classes, this is probably the least practiced form of a line. We do a ton of stuff with slope-intercept form. We don't do very much with point slope form. So I like practicing it because we need practice with it. So to go through point slope form, I'm going to do like I did on that last example. I'm going to start with y minus y1 equals m x minus x1. I'm just writing that so I remember point slope form. I'm going to plug in the slope was -3. My y value was positive 1, so that's y minus 1. My x value was x minus negative 4. So this is going to look a lot like that last problem on the lab that we did earlier. So I'm gonna make this look a little bit better. It's going to be x plus 4 in the parentheses there. Still got the y minus 1. What do I do next? Yeah, distribute the negative 3 to both of those things. So that's going to be negative 3x minus 12. And I got the y minus 1 still over there. To get into slope-intercept form, I just need y to be by itself. So what do? Add a positive 1 to both sides. I'm going to add it to the negative 12 that's there. And I have negative 3x minus 11. There's slope-intercept form. That's going through point-slope form. Now, is that the only way to get slope-intercept form? Absolutely not. And this, I do it this way because my wife does it this way, and she teaches Algebra 1 at the other school. And so that's what we each call each other's school. It's the other school. Now, if I start with slope-intercept form, I know the slope, but I don't know the y-intercept if I'm starting there. So I'm going to plug in the slope of negative 3. And then I'm going to take that ordered pair, that negative 4, positive 1, and I'm going to put this negative 4 in the place of x and the 1 in the place of y. B is the variable now. So I'll replace the x with the negative 4, and I'll replace the y with the positive 1. That was the ordered pair they gave me. So the negative 3 was my slope. That's where I put it. And then I put the x value of my ordered pair and the y value of my ordered pair. So far, for each of these, I've done the same kind of step. It's just one step there. And now the next step is multiply negative 3 times negative 4. What's negative 3 times negative 4? So we got 1 equals 12 plus b. And then I need to get b by itself. So I'm going to subtract 12. That's negative 11, isn't it? Now I have the y-intercept is negative 11. Now I go back and rewrite my equation. Y equals negative 3x minus 11. Same answer. I went a different road to get there. I don't care which way you do it. I really prefer this way just because it makes me do point slope form. And, if I know point slope form, I know all I got to do is get y by itself, and I got slope intercept form. This way, this is the reason I don't do it this way most of the time, is because I'll always have students that will make a sign mistake right there, or they will forget to go back and rewrite their answer at the end. With point slope form, I have to write my answer at the end because I did the work to get there. Here, I did the work and I got b by itself, and I feel like I'm done, and I forget to write y equals mx plus b out of that. So either way works. I don't care which way you do it. You may have done it like this in high school. You may have done it like this in high school. You may not have done this at all. You may not remember high school. That's okay. You can still do it. Okay, it's just step by step kind of stuff. Okay, let's go to the next example, and we'll get to choose which way we go about doing it. Okay, so example E, we want to write the slope-intercept form equation. Slope-intercept form for a line through negative 3, positive 2, and 2, negative 4. Okay, that should look familiar. It's the same points we had on the example. What was it? C. No, it wasn't C. It was B. Example B. So if I'm going to write slope-intercept form, the first thing I need is a slope. I don't have that. But I do have two ordered pairs. So I can use my slope formula, y2 minus y1, x2 minus x1. And I'm going to find my slope. So m equals. Pick a y value to start with. If I start with 2, then I subtract -4. And then on the bottom, I got to start with -3 minus 2. I did it the opposite way that I did it on example B on purpose. So I can show you it works the same way. That's going to be positive 6 over -5, which is just -6 over 5. That's my slope. I need that. Now, here's the beautiful part about going to slope-intercept form, that it doesn't matter which ordered pair you pick. We will all get to the same slope-intercept form equation if we all do it correctly. Okay, we got to deal with fractions in this one, so that's just part of the game. But I'm going to do the point slope form of this, and I'm going to use -3, +2. That's the point I'm choosing to use. So I've got y minus 2 equals -6 over 5, x minus -3. Yes, ma'am.
So, why, I know why you did the 2 minus 4, because to do the opposite, so you can do that?
Yeah, you can do it in any order you want to, as long as your ordered pair is vertical. There. So the ordered pair was -3, 2. Look at there, -3, 2. This ordered pair was 2.
Okay.
And I just switched it
Okay.
just for
I was
no
just
good
wondering.
reason,
Okay.
really. But you can do it either way.
Okay.
As long as your x and y are together vertically,
Okay.
you can do that. So that way if you accidentally, you don't have to stop and start over. You can just start with that. All right, so I'm doing it the point slope form way this time. So I've got a double negative right there, so I'm going to swap that, make it a x plus 3. So that's going to be -6 over 5, parentheses, x plus 3. And then we got the y minus 2. So the next step is distributive property. I've got to distribute this fraction to all of that, which not easy, but not hard. I got the x part done. Now -6 over 5 times 3 over 1. -6 times 3 is -18. 5 times 1 is 5. Top times top, bottom times bottom. It does not reduce. So I'm leaving it at -18 over 5. And then I got y minus 2 there. I'm almost to slope-intercept form. I am one step away from slope-intercept form. It took me 1, 2, I will say 3 steps to get there. Now, step 4 gets me in slope-intercept form. I'm going to move this 2. How do I move that 2? Nope, it's already subtracting. Add it. Yeah, I need to add 2. So I'm going to add 2 to that -18 over 5. So that's -6 over 5x. And then 2 is really 10 over 5. So -18 plus 10 would be -8. And there's my slope-intercept form. Now, the really cool thing that I think makes this, if I go through point slope form and I use the other ordered pair, what was the other ordered pair? 2, -4. The y minus -4 equals -6 over 5, x minus 2. I'm going to go through the same steps, and I want you to see that it ends up being this same slope-intercept form equation, no matter which ordered pair I picked. Because they're not going to tell you which one to pick. They're just going to say, do it. So this becomes y plus 4. This is negative 6 over 5x plus 12 over 5. So I'm just going ahead and doing that distributive property. That's what I did there. Went ahead and did the distributive property. Now I got to get y by itself. I'm one step away. Subtract 4. So 4 is negative 4 would be the same thing as negative 20 over 5. 12 minus 20 is negative 8 over 5. And that is the same slope-intercept form as I got using the other ordered pair. So slope-intercept form is the same no matter which ordered pair you pick. Now the point-slope forms looked a lot different, but the slope-intercepts should be exactly the same. So that's always a good way to check to make sure you got it right, is using either of the ordered pairs. You can still do it the other way too if you wanted to, where you get the y equals negative 6 over 5x plus b, and you pick one of the ordered pairs. I'm going to put the negative 4 in there. That's going to be negative 12 over 5 plus b. And then if I add 12 over 5 to that, nope, I'm doing the common denominator before I move my stuff. Sorry. Brain's working faster than my hands. And then that's going to be the same negative 8 over 5. So my slope-intercept form is negative 6 over 5x minus 8 over 5. All 3 roads lead to the same place. Okay? We talk about driving to Jackson. There's a whole lot of ways to get there. Right? I could just get out here on the bypass or on 45 and go straight up. If I felt really adventurous, I could take a right when I get to Pinson and go out toward Pinson Mounds and then take a left at the end of that road and go a little ways. And then I can't remember the name of the road, but I know the road when I get there, and you can take a right and it'll take you in. You'll come in right behind Jackson Stadium there. Blue Goose is out that way. Yeah, it's a weird. There's nothing else out there very much at all. So just be aware. If you have trouble, there's nothing out there other than houses and a bunch of empty farmland. But Blue Goose is out that way. But that's a different way of getting there. It's kind of the long way around it to get there. Some ways, but in this case, I don't think one way is any better than the other. They all take about the same number of steps. You just pick whichever one you feel most confident in. Okay? I think this way with the point slope form makes you learn the point slope form better, which you need to know anyway, which is why I do it that way. All right. Moving on. The last form is called standard form. And even though it is the standard form, it is probably the form we do the least with in algebra classes. I don't know why they decided that it was standard form, but standard form looks like this. It has x and y on the same side. It has a few rules about it. The first rule is that A, B, and C, and I use my little shorthand, let me change that to an and, are not fractions. And if you're not a fraction, you're not a decimal. Okay? No fractions, no decimals. The other rule is that the GCF, the greatest common factor of A, B, and C, is 1. Now, when I went through Algebra 1 back in the 90s, dates myself there. Back in the 90s, there was a third rule. Over the course of algebra kind of evolving a little bit, they've decided that rule doesn't really matter that much. Okay, so there's only these two rules. You may have learned in the Algebra 1 class or something when you were in high school that you couldn't have a negative in front of the x. That rule is not applied anymore. Most every textbook that you see now does not abide by that rule. They abide by these two, but they don't abide by the negative thing out of that. Our author doesn't abide by the textbook we're using. Doesn't abide by that rule about the no negative in front of x. Okay? So x and y are on the same side. The a, b, and c are just numbers. They're numbers that are not decimals and not fractions. Okay, so we got to deal with that a little bit as we go through here. Okay, so let's start off easy with example F. Let's say we had the instructions were to write y equals negative 3x minus 11 into standard form. So this is really as simple as they can make this problem. Okay. So if I'm going to write that in standard form, I need x and y to be on the same side and a plain number to be on the other side. So what do I need to move from the right-hand side over there with the y? 3x. How do I move it? I'm going to plus 3x. And then that's going to get rid of it over here. That's going to leave me negative 11 on the right-hand side. On the left-hand side, I'm going to write it in order. X comes first. So that's 3x positive. What kind of y is it? Positive or negative? Positive, because it doesn't have a negative sign in front of it. So that's plus y. All right, so let's check our rules. X and y on the same side. Check. A, B, and C. So the number in front of x is a 3. What's the number in front of y? 1. And then C is negative 11. Are any of those fractions or decimals? No. Rule number 1, accomplished. Rule number 2, the greatest common factor of the number in front of x, the number in front of y, and the last number is 1. That means you can't divide everybody by the same thing other than 1. We got a 3, a 1, and 11. There's nothing that goes into 3 that goes into 11 other than 1. So that right there is in standard form. That took one step to get us from slope-intercept form into standard form. Okay, so let's go to example G. Write y plus 7 equals 2/3 x minus 6 in standard form. What form is it in right now? Point slope form. Okay, so to write this in standard form, I'm going to get it into slope-intercept form, and then it's a one-step problem, maybe, hopefully. So my first step is to get the 2/3 over there into that stuff. So that's going to be 2/3 x minus what? What's 2/3 of 6? 4. And I have the y plus 7 still over there. Okay, moving the 7's a great idea. Get those like numbers together. So minus 7. And so that's going to give me y is equal to 2/3 x minus 11. That looks like slope-intercept form because it is. So we took something that was in point-slope form and we moved it to standard form, or excuse me, into slope-intercept form. The next step is to move that into standard form. So to move it into standard form, I need x and y to be on the same side before I do anything else. So I need to move that 2/3 x over there. Subtract it because it's positive. If I subtract 2/3 x, that's going to move it over there. And there's going to have negative 2/3 x plus y equals negative 11, which is almost standard form. It violates one of my rules, though. Can't be a fraction or a decimal in front of one of the letters. So this is how we get rid of that. The denominator is 3. So if I multiply each side by that denominator, okay, so use the denominator to get rid of fractions. Okay, so 3 times everything in the parentheses here. 3 times negative 2/3, it's going to be negative 2x. 3 times y is 3y. And then 3 times negative 11, negative 33. I don't know why I wrote that like first grader, but fix it. Now, that satisfies the rule of no fractions. And it also satisfies the rule that you can't divide everybody by the same number other than 1. Because 2 and 3 don't have anything else in common besides 1. And 2 and 33 don't have anything else in common besides 1. So that fits the rules for standard form. So there's my standard form for that. Boom. Okay. So started in point slope form. We got it into slope intercept form. We moved it around until we got x and y on the same side. And then we used the denominator of the fraction to get rid of the fractions. You got to multiply by the denominator. If there's more than one denominator, use a common denominator. Okay, if there's more than one fraction. Okay. There usually isn't in Math 100, just to be honest with you. All right, let's try example H. Okay. Example H. Write the equation in all 3 forms for a line through 1, 1 and 2, 4. We have 2 points. We want all 3 forms. So we need to do point slope form. We need to do slope intercept form. Then we need to go to standard form. I would do it in that order because it's easy for me to take a point slope form problem and turn it into slope intercept form because I just got to get y by itself. Then it's easy for me to take a slope intercept problem and get it into standard form because I've just got to get x and y on the same side and then get rid of the decimals and fractions if I have them. Okay, so I'm going to start with what? What do I need to find to start anything? Slope. So m equals y2 minus y1 over x2 minus x1. I've written that about 17 times over the last 2 weeks. I hope we've got it memorized by now. So 4 minus 1 over 2 minus 1. So that's 3 over 1. So my slope is 3. So my slope is 3. So now I can start my point slope form. Remember point slope form, y minus y1, m, x minus x1. So I'm just writing that form so that it helps us memorize that and have it in our memory. That's how I memorize a lot of things. If I need to memorize something, I just rewrite it over and over and over. It's the things I don't need to memorize that seem to stick. It's dumb movie quotes that have no meaning to life at all. They're just funny. And what planet Luke was on in Star Wars, stuff that really doesn't matter. Well, it does, but it doesn't. What pitch I threw in high school and gave up a home run. Things that really, why would I even remember that? But it's there. But rewriting stuff helps me remember things that I just can't get stuck. So, which ordered pair do you want to use? Let's pick one together. 1, 1. Why would we pick that one? Because you can't screw it up, right? It's the same number twice. So I can't put one of them in the wrong spot, right? So that makes it easy. 1, y minus 1 equals 3, x minus 1. Ooh, man, I'm already done with point slope form. Check. I didn't even have to take care of any double negatives. That's nice. What's the other one? What would be the other point slope form?
Y equals 3x minus 2.
That'd be the slope-intercept form. Or that'd be, what's over here with y? You got part of it. What's over there with y if we use the other ordered pair? Y minus 4. Both of those are correct for point slope form. I don't care which one is the one you use. You got that 3 and then the x minus 2, and then you got the y minus 4 over there. You got to have that to be point slope form. Either one of those. You don't have to do both. When you go to do this for practice, you don't have to do both. Just do one of them. But I want you to know you could do, just because, Abby Sue does the 1, 1 ordered pair, and Lauren Kiley says, I'm going to do the 2, 4. And it's fine. Doesn't matter. They're both correct. Now, when we go to slope-intercept form, we both better get the same answer. So if I distribute the 3, I'm going to have 3x minus 3, and then I'd add 1. So that's going to be my 3x minus 2. That's what Jason said back there. If I do the same thing over here, I'm going to get 3x minus 6, and I got the y minus 4. And if I add 4, I still get y equals 3x minus 2. So no matter which direction I go with the ordered pairs in point slope form, I will get the same slope-intercept form. So either that's slope-intercept form. So slope-intercept. And I'm just going to abbreviate slope-intercept. Which makes getting standard form pretty easy on this one because I don't see any fractions in that problem. That's good news. So standard form, I got y equals negative 3, or not negative 3x, positive 3x minus 2. How do I get into standard form here? Minus 3x. Boom. That's going to be negative 3x plus y is equal to negative 2. Why is this also correct? This is where math starts getting crazy. Why are both of those right?
You just flip the sign.
I flipped all of the signs. I didn't just flip one of them, I flipped everybody. And that's okay. As long as you do everybody, it's legal to do that. But both of those still meet the rules for standard form. Okay? So this one, negative 3, positive 1, negative 2, they don't have anything in common. 3, negative 1, 2, they still don't have anything in common. So there's nothing else. And there's no fractions or decimals in it. So both of them are correct for standard form, but they just got opposite signs on everybody. And that's absolutely okay. Both of them are correct, though. That's probably the part most people kind of gripe a little bit about math is that there's sometimes more than one answer that's right. Yeah, but they're the same thing, usually. All right. So the next thing, still same section. This is the long section. The second section is pretty short. So this is the long section for tonight. There's always one that's long and one that's short. Parallel lines. What can y'all tell me about parallel lines? What do you know about them? Say it again. They never meet. Okay, parallel lines never, and I'm going to use the word intersect or meet. What else do we know? Maybe we remember from our younger days and out in high school math, geometry class. Vaguely, our mom teaches geometry. Yeah.
They're gonna have identical X or Y values.
Not necessarily identical X and Y values, because think about the lines on the wall, like between the mortar lines on the bricks there. This line, that point right there, has got a different X and Y value than this one here, but those lines are parallel to each other. So they don't just have the same X and Y values.
Identical slope.
That's the one I'm going for. The identical slopes. They have the same slope. That's the one we need. They have the same slope. That's the one that's the most important to us, is that they have the same slope. So let's use that to help us do some problems. I think we're on example I. So we're going to write the equation of a line parallel to 2x plus 5y equals 4 that passes through 3, 5. Let's do all three forms, just to get the practice. More practice, more better, right? All right. So Jason told us that the parallel lines have the same slope. I have an equation that's in what form? Standard form. Can I get the slope from that really easily? How?
The slope?
Yeah, the slope.
No.
Not real easy. So what form does give me the slope real easy? Slope intercept form or point slope form. I'm going to go to slope intercept form because that's easy to do from standard form. So all I got to do is get y by itself and I'll get the slope that I need. So I'm going to subtract 2x. It's going to give me 5y equals negative 2x plus 4. And then the last step to get the slope would be get rid of that 5. So I'm going to divide by 5. And y is equal to negative 2/5 x plus 4 over 5. What is the only part of that problem that I care anything about? The negative 2/5. That is the only part I want. The rest of it can kick rocks because I don't need it. So I've got the slope of my new line. Okay? So my slope is negative 2/5. I have the ordered pair 3, 5. So I'm going to start in point slope form. I only have one ordered pair, so there's only one point slope form to this. So my point slope y minus y1 equals m x minus x1. Mr. Isbell, quit writing that. We got it. We know it. Just making sure. What goeth where? As the King James would say. Y minus 5. Good.
Equals negative 2 over 5 x minus 3. or x minus negative 3. Positive 3. X minus 3.
I'm gonna let you settle on something. So is it x minus 3 or
X minus 3.
okay? I just want to make sure. Don't want you to. There's my point slope form. Yippee! Okay. Let's go to slope intercept form from that. So I have y minus 5 is equal to negative 2/5. Whoops. My mouth, my hands not working together. Plus 6 over 5. How did that become plus 6 over 5? Double negative. Negative 2/5 times a negative 3 becomes a positive. 2 times 3 is 6. 5 times that 1 that 3 is over gets me that positive 5 on the bottom. Okay. We're almost to slope intercept form. One step away. What was that? Add the 5. Yeah, that's exactly what we should do. And that's going to be negative 2/5 x. We're adding there, so this is 5 over 1. I'm going to multiply by 5 and 5, so that's going to be 25 over 5. Is that 31 over 5?
Mm-hmm.
If you did that with the calculator, which I'm absolutely okay with, so we're taking that 6 over 5. So alpha y equals is where your fraction button lives. So we got 6 over 5, and then go to the right to get out of that fraction, and then I'm adding 5. That just saves me from having to do the common denominator stuff, and it does it for me. 31 over 5. There's my slope-intercept form. Okay? Let's go to standard form for that. So I've got the y equals negative 2/5 x plus 31 over 5. Now what? Yeah, add the 2/5 x. Good job. I meant to do that in a different color. I'm going to. Plus. Where's my blue marker? There we go. Plus 2/5 x plus 2/5 x. So I have 2/5 x plus y is equal to 31/5. I've got a rule violation here. Got fractions. So how do I get rid of the fractions? Multiply by the denominator of that fractions. I only have one denominator here. It's a 5, so I'm multiplying both sides by 5. Distribute on the left side. The right side's easy. The 5s just cancel out, and I get 31. The left-hand side, I got to do a little bit of work there. What's the x going to be? 2. 2x. And then plus 5y. And there we have good old standard form. So same work, but parallel lines. You steal the slope from another line. That's the same. Everything else is the same, but we steal the slope from the line they gave me. Okay. Everybody a chance to catch up there. There's a lot of work on that. Get all 3 forms. And I'm just practicing all 3 forms. On the quizzes and the test, it's only going to ask you for one of them. It's not going to ask you for all 3. But you need to be able to do any of the 3. So that's why I'm practicing all 3 of them. All right, so we did parallel lines. Perpendicular lines. What do we know about perpendicular lines? They intersect kind of at a special way, though. At 90-degree angles. Spell angles there. 4 right angles where they intersect. So, like up here in the corner of the room there, this wall is probably not perfectly perpendicular there because I've never been in a building that is, but it's pretty close to 90 degrees there where those two walls meet at 90 degrees. That's perpendicular. Now, kind of in the same vein as we did with parallel lines, what do we know about the slopes of perpendicular lines? Or maybe we remember. This one's a little weird. Maybe we remember it. Opposite what's? Opposite signs. There's part of it. So Haley got us part of it. They're opposite signs. So the slopes are opposite reciprocals. And the way that I remember learning this was you flip and change sign. Reciprocal of a fraction is flip it over, and then we swap the sign. That creates the slope for perpendicular lines. So if you had a slope that was positive 2/3, which would be going up and to the right, the reciprocal of that would be flip it over. So that 2/3 flipped over becomes 3/2, but then I have to change the sign so that it becomes perpendicular. Okay, so they're always going to be opposite signs, but flip them over. Okay, flip and change the sign. Okay, so let's get us an example of that. This is the last example of this section, just so you know. It's been a long day. So, example J. Write the equation of a line perpendicular to negative 3x plus 7y equals 826. That passes through negative 14, positive 10. Okay. What do we got to do? We're going to write an equation of a line, and we're going to do all 3 forms again, just like we've been doing. I need what to start with? I need a slope to start with. So I got an equation that's in what form? Standard. I need it in slope-intercept form. So let's get there. How do we get there? Move the 3x. So it's a negative 3, so I'm going to add 3x. That's going to give me 7y equals 3x plus 826. Divide by 7. That's going to be y equals 3/7 x plus 118. It goes evenly. Hey, I picked out some good numbers there. That's nice. What's the only part I care about? The slope there. But I'm doing perpendicular, so I got to think perpendicular slope. Yeah, flip it over. Negative 7/3. I always thought this was the coolest abbreviation for perpendicular. It's an upside down T. That's abbreviation for perpendicular. If you don't write out perpendicular, you do a T upside down. That's perpendicular. Geometry class. I thought that was the funnest abbreviation. I don't know why. I guess just because I'm a loser, but it's okay. All right. So we got a slope. We got a point. So we're going to start in point slope form. y minus y1 equals m x minus x1. Plug in the stuff. What we got? Which one? 10, because that's the y value there. So y minus 10. And then in the m's part, I got the negative 7/3. And then inside the parentheses, I've got x minus negative 14, which we can make a little bit better at the double negative. Now, if you want to do that in one step, I'm absolutely on board for that. That you would write your answer as y minus 10 equals negative 7/3 x plus 14. If you went straight to that, I'm good with that. There's my point slope form. Isn't that lovely? Now let's go to slope intercept form. Now I'm just abbreviating slope intercept. What's the first step? Distribute. So I got the y minus 10 equals negative 7/3 x minus 7 times 14. 7 times 7 times 10 is 70. 7 times 4 is 28. Added together would be negative 98 over 3. Well, we're almost there. One more step. Add the 10. Plus 10. 10 is equivalent to 30 over 3. So I'm adding 30 over 3. So that's going to be y is equal to negative 7/3 x minus 68 over 3. And there's my slope intercept form in that equation. That wasn't too bad. Now we got fractions to deal with, but we're going to go into standard form next. So I'm going to do what? How do I start? Add the x over to the other side, right? So add 7/3 x. I got 7 over 3x plus y is equal to negative 68 over 3. But there's fractions, so we got to get rid of them. How do we get rid of them? Denominator? Yeah, that's right. So I stutter over that word too. Too many N's in there. It's like I can't say aluminum, so I say aluminium because I can't say aluminum.
You say what?
Aluminium.
That's the proper way to say it.
That's actually the right way to say it.
That sounds like the French version.
It's the British pronunciation, actually, but it's actually how it's enunciated according to the origin of the word and all that fun stuff. So, yeah.
How it's spelled.
Well,
It has to
We'll leave
come
that
from
up to
Latin because that's
interpretation.
very similar to the French version.
yeah, it is. And most everything in science is based off of Latin or Greek stuff. So 3 times 7/3 is going to give me a 7. 3 times y is my 3y. 3 times the negative 68 over 3 just gets rid of the 3 and gets me the negative 68. 7, 3 don't have anything in common, so it doesn't even matter if there's anything in common with 68. There's my standard form. We're good to go. So, all right. So that's section 2.5. If you wanted to practice 2.5 out of the textbook, numbers 1 through 51, odds would be a good place to go. No matter if you have the 7th version or the 8th version of the textbook. If you had an older version that you borrowed from somebody, that's fine. You still get the same practice. Okay. All right. So that's section 2.5. One more section to go tonight, and this one's shorter. It has 1, 2, 3, 4, 5 examples. So I don't think we're getting out of here by 6, but we're going to get out of here before 6:30. So that's a good night. It's going to be a great night for us. So solving linear inequalities. So this is very similar to solving the equations that we did in labs tonight. That's why all this stuff goes together in this particular test. All right, so the first example, we're just going to jump into solving this. 3x plus 7, write the 7 correctly, is greater than 13. So greater than symbol, if you have trouble remembering those, and this is a real thing, take your left hand, put it in front of you, and make an L. Turn it a little bit. That's a less than symbol. So the other one's got to be the greater than symbol. Okay? That's how literally how you can help remember which one's greater than, which one's less than. Because it matters. Okay? It'll matter more later on. Not it matter as much here, but it does matter. Okay? So being able to read that correctly. So this is a greater than symbol. So solving that is the same steps as solving an equation. So what do I do first? Subtract 7. Boom. 3x greater than 13 minus 7 is 6. And then divide by 3. Now, the only thing I've got to remember when I do division or multiplication with inequalities is that if I divide or multiply by a negative to solve it, I got to flip that symbol around. That's one of the rules. Okay? And the reason is because it changes the sign of the answer, and that's going to change what direction that goes as far as the graph goes. So we have x is greater than 2. We didn't divide by negative, so I didn't flip it over. There are 3 different forms of the answer we need to be able to write. Okay? The first form is called the set form, or set notation. So a little curly brace, we're going to write an x, and then a straight up and down bar, and then the inequality, x is greater than 2. That is set notation. That says all the x's, as long as x is greater than 2, work for this inequality. That's set notation. The next way is a number line. So a graph on a number line. So I'm going to draw myself a number line. Doesn't have to be real long. I'm just, I'm going to put the answer I got in the middle. And I'm going to put the numbers around it that go there. So there's 1, there's 0, there's -1, there's 3, 4, 5. Just a couple or 3 on each side. Doesn't have to be huge. Okay? Now, greater than 2 means we're going to start at 2, but we do not include the 2. Now, the way you did it in high school may be different than what we're doing here. In high school, you may have done it like an open circle and then a line that went that way. In college, we're going to write it like this. We're going to put a parenthesis right there and then go into the right. That parenthesis means I'm not including the 2 in my answers. Just like an open circle would mean I'm not including the 2 in the answer. What that helps me do better is the third form of the answer, which is interval notation. Remember we talked about this a little bit when we were doing domain? So the interval notation. Interval notation starts at 2, but it doesn't include the 2, so that's parentheses 2, and then this line goes forever that way. So that's going toward positive infinity. And we always put a parenthesis on our infinities. So we got 3 different types of answers that we got to be able to do. Set notation, number line graphs, and interval notation. To me, interval notation and the number line graph go hand in hand. They are the same. Okay? So if you're struggling with interval notation, the number line is really where you can learn to do it better. Okay. Let's go to another example and do it again. Example B. Negative 3x plus 5 greater than or equal to negative 7. So it's got the equal to mark underneath it there. That little bar underneath, that's the equal to mark. So this is greater than or equal to. But the solving is the same way as we solve an equation. So what's our first step? Minus 5. That's going to cancel out. I got negative 3x greater than or equal to negative 12. Next. All right, now dividing by negative. Remember what I said earlier. The rule is if you multiply or divide by a negative to solve, you got to flip that symbol over. So that's going to become a less than or equal to positive 4. The reason it does that is because it flips the sign on the other side. That went from a negative 12 to a positive. So that flipped us on the other side of the 0. We got to flip the symbol around. Now, the set notation should be the easiest one because once you get here, the set notation is just build that around there. All x's, whatever variable is in there, x is what I'm using, but all x's as long as x is less than or equal to 4. That's set notation. That should be the easiest one. Now the number line, I like to do it next because it makes my interval notation the easiest. Or makes it easier for me to interpret to the interval notation. So I'm going to put the 4 in the middle. That was the number I had for an answer. I'm going to go 5, 6, 7, 3, 2, 1. Okay. So I'm going less than or equal to 4. So the symbol that I'm going to put there is going to be a bracket. So a square bracket like that. And then it's going less than, so it's going to the left. That's the number line.
Does that change? Okay, the greater than or equal to sign, does that change? I'm looking back at my notes. I don't think maybe I drew the first one, right? First number line. So it wasn't a greater than or equal to, it was just a greater than symbol. Does that change where that bracket sits?
No, it's right on the 2 there. It's right.
This one doesn't actually include the 2, where this answer includes the 4.
Right.
So what, you don't know the difference with the...
Yeah, the difference is I use a square bracket instead of a parenthesis.
Oh,
that's the difference.
Okay, so the first one is a parenthesis.
The first one is a parenthesis, and then this one's a square bracket. That's how you note the difference. I'm glad you brought that up because that's very important. So the square bracket notes that I'm including the 4. The parenthesis is I'm not including it. So that's the difference in those two. Now, interval notation is reading the number line from left to right. So left to right, my answers are way out here. Where's that going? Negative infinity. So I'm starting at negative infinity, and we always put a parenthesis on the infinities because we can never really get there. You can't include infinity because it's always more. So we always put a parenthesis on the infinities. And then I'm going all the way up to the 4, and I'm stopping there, but I'm including the 4. So I use a square bracket on the 4 there. And there's my interval notation for that. All right. Let's do another. Example C. Let's do one that's got variables on both sides. 4 minus 3x less than or equal to 7 plus 2x. Okay. Now, you can choose which direction you want to go to put your x's. I prefer to have the x's on the left. That just makes my inequalities easier, my set notation easier, my graphs easier. Just makes it easier to read. But you could move the x's to the right if you wanted to. But at the end of the thing, we're going to have to flip them back around anyway. So if I'm going to move my x's to the left, that means I'm going to move the stuff that ain't got an x to the right. So I'm going to move this 4 by subtraction. That's going to give me negative 3x less than or equal to 3 plus 2x. I'm doing this in 2 steps. You are very welcome to do it in 1 step. To move the 2x over there with the negative 3x at the same time. I'm doing it in 2 separate steps. But I would expect that as you do these, you're going to say, well, I can do that all at once. That's fine. But you don't have to. So the next step is I'm going to get my 2x over there with the negative 3x by subtraction. Okay. That's going to give me negative 5x is less than or equal to positive 3. Okay. I am 1 step away from having the answer here. What do? Divide by negative 5, and because I'm dividing by that negative, I flip the symbol to be greater than or equal to, and I got the fraction negative 3/5. So in my set notation, all x's as long as x is greater than or equal to negative 3/5. That curly brace did not work out right. That's better. That's our set notation. Now on the number line, kind of you got a little bit of freedom on how you do this. I'm going to show you how I like to draw the number line, and then you kind of do it the way you want to. I'm going to put that fraction in the middle again, the answer, negative 3/5. And then when I go smaller than that, I'm going to go negative 4/5 and then negative 1, because that's negative 5/5, right? And on the other side, I'm going to go negative 2/5, negative 1/5. I just changed the numerator, going to the left and right. That's how I usually do it. That way I don't have to estimate where negative 3/5 is between 0 and negative 1 and that kind of stuff. So it just makes my anything make life a little less stressful. I'm a big fan of it. Okay. So the next thing is how do I draw that on the number line? All right, so bracket at the negative 3/5 going to the right because it's greater than. So bracket and then to the right. Very good.
I have a question.
Yes, sir.
Is there a wrong answer to what you put on that number line?
Not necessarily.
Would it matter?
If you use, as long as your answer is in the correct place and your numbers are in order. Like you could do a number line that has maybe you got 0 here, negative 1, negative 2, and positive 1, and you went and you said, okay, negative 3/5 is about right there, and then did this. That's perfectly fine.
Almost exactly what I was.
Okay, and that's fine. Either way is fine. This is just how I like to do it. Kind of really need to be able to recognize either, because I never know how they're going to do it on the final exam, because they do it different every year. They just kind of mix it up. But just being able to recognize, hey, I know my answer's right there. I've got the bracket and going to the right. I just got to have my numbers in the right order on the number line. So in interval notation, what's the interval notation for this? No matter what your number line looks like. To infinity, and bracket on the negative 3/5, parenthesis on the infinity. I think over the last, I've been teaching Math 100 about 10 years now, most of the time on the final, the inequality stuff, they usually have interval notation as the answer choice. Just because it's a little less, leaves less to interpretation about the number line. But they usually do interval notation. They haven't always done that. Sometimes I've seen them do the set notation. I've seen number lines on there, but it's not always number lines. It's not always set. It's not always interval. But interval seems to come up more often. Okay. So far we've had an X on one side or the other or both sides, and we kind of moved it around. Let's look at a inequality that has an X in the middle. The middle, you say? I don't know why I wrote a 3. It should be a -2, sorry. Less than 5 plus 3x less than or equal to 20. So this is a compound inequality is what it's called. I like to think of it as a sandwich. You have numbers on each end. You got the X in the middle. Okay? It's kind of sandwich there. Now, what you want to do is take the stuff out of the sandwich that you don't like. Okay? I want X is the only thing I want in the middle of my sandwich. So I'm going to get rid of the stuff on the middle that isn't an X. So the first step here is going to be get rid of the 5. I'm going to subtract 5 from the middle. But if I subtract it from the middle, I gotta move it outside on both ends. So I'm subtracting 5 on both ends. Whatever happens in the middle happens on each end. That cancels out the 5. I get a -7 over here is less than 3x is less than or equal to be 15. And now I've almost got X by itself in the middle. I got that 3 that's still hanging out in there. So I need to use the inverse operation to get rid of that 3. So how do I get rid of that 3? Yeah, divide by 3 in the middle. If I divide by 3 in the middle, I got to divide by 3 on the end and on that end. That's a positive 3 I'm dividing by, so I'm not flipping my symbols. So the X is now by itself in the middle. I've got a -7/3 on the left. On the right-hand side, what do I have? 5. It goes evenly. Okay. If it didn't, I would just reduce the fraction. Okay. Now, the thing you've got to look at here is that in order from smallest number to biggest number? Yes. If it's not, you've got to turn it around. It usually is, but sometimes some weird things happen. Okay, so my set notation, I'll go ahead and write that. All x's as long as -7/3 is less than x is less than or equal to 5. So there's my set. My number line. So this one has an integer and a fraction in it. That when it's mixed like that, I usually will do just integers on my number line. And I just got to make sure I got room for everybody. So I'm going to start up here at 7, 6, 5, 4. Keep going down. How far do I need to be able to go here? -7/3 is -2 and some change, right? So I need to go to at least -3. And then I'm going to mark where -7/3 would be on the number line. -7/3 would be -2 and 1/3. So that's going to be -2 and 1/3 is about right there. That's the -7/3. Up here at 5, that's where that's at. So what symbol goes on the -7/3? Parenthesis, because it doesn't have the equal to mark. What symbol goes on the 5? a bracket. Notice how they're both opening to the inside, because where are our answers? In the middle. X is in the middle, so all the answers are between those two. That's a compound inequality. Now, the compound inequalities, the interval notation is the easiest kind because you got everything right there. You got your end piece for the interval notation. I can't write interval. So I'd have parenthesis, got my negative 7/3, comma 5, bracket. It's just copying the number line. That's the nice thing about the number line and interval notation, is they really just copy one another. One more. Yeah, one more example. Let's get one that does something weird. Because the ones that do weird things are the things that give us trouble, that are going to confuse us when we go to do these. Okay, so let's do a weird one. It starts out pretty innocent and looks a lot like the last one we did. So 16 is less than 4 minus 2x is less than or equal to 18. So it looks like a sandwich like I had before. So let's get the stuff out of the sandwich we don't like. So let's get rid of the 4. How? Subtract 4. So minus 4 all around. That works out nice because 16 minus 4 is 12. And I got a negative 2x, and then 18 minus 4 is 14. Uh-oh. What next? Oh, divided by negative? What? Okay, so that's going to give me negative 6 is greater than x is greater than or equal to negative 7. So it just turned them all around and swapped the signs to negative. Now, is that in order smallest to biggest? No. Because negative 6 is bigger than negative 7, number line wise. So we got to turn this thing around. So when I take that thing and turn it around, the negative 7 comes first, the x is still in the middle, and the negative 6 is on the other end. What symbol goes between the negative 7 and the x? Less than or equal to? What symbol goes between the x and the negative 6? Less than. Okay.
I mean, if you just look at what we're simplifying from, just the relationship stays the same.
Exactly. That's exactly right, Jones. The relationship stays the same. And I really dislike this example, but it really does work. And elementary school teachers use it all the time. The alligator eating the bigger number, right? So right now in the green one, the alligator's eating the X. If I flip it around on the X one, alligator turned around, but he's still eating the X right there, right? Feed our X's to the alligators, right? No, don't do that. That's bad. Don't do that. Now we got it in the right order. Now let's put it in the forms. So we got the set form. All x's as long as negative 7 is less than or equal to x is less than negative 6. That's pretty easy and boring. Number line wise, you don't have to go far here. I spread it out quite a bit there for no apparent reason, but what symbol goes on the negative 7? Bracket. What symbol goes on the 6? The negative 6, excuse me. Parenthesis, because it doesn't have the equal to mark. Where are my answers? In between. Somewhere between memory and me. So there we go. There's our graph. That makes the interval notation really super easy. What's the interval? Bracket -7, -6, parenthesis. Boom. In section 1.7, if you want to practice from the textbook, if you go to 1.7 in whatever version of the textbook you have, you can do those problems and it'll get you some practice on this stuff. Okay. So on this week, you got quizzes for 2.5 and 1.7. That was 2 sections we did. Okay, so you got quizzes for 2.5 and 1.7, and then you will also be getting a review in the message. Okay?
Interval for exam
B. D or B? That one. Okay. All right. So we got the 2 quizzes. You'll get a review for the test. You also have a practice little short thing. It's just, it really isn't for a grade at all. It's just to make sure that your extension works the right way.
Proctorio only works on Google Chrome, and if it's updated to the latest version.
There you go.
That should be your only problem.
That's what she said is the right thing. Google Chrome, latest version of that, the Proctorio extension on that. So I'll have a little practice quiz for you there, and then the test will be posted on Monday. It's due by the end of the night on Tuesday. 2-hour time limit, only 1 attempt on it. Okay. If you've got questions about the review, email those to me this week, and I'll get back to you on how to work them and all that fun stuff so that you're ready for the test. Okay. Other than that, have a great week, folks.